So we're going to talk about circle graphs today, and we went through these things just a second ago, but I'm just going to re-hit them so it's on here. Okay, circle graph is a graph that displays parts to a whole. So for example, all of these percentages right here, add it to 100% because 100% is a whole. We have known that all of our math careers, right? 100% is a whole. In a circle graph, the percents added to 100. The data represented in the circle graph can be used to solve problems including part to whole comparisons and equivalence. So that's when I brought in, we need to know that that's kind of the thought behind it. Right here, they're talking about, this represents the flowers in a flower garden. If there are a total of 150 flowers. So they're saying that 12% of the 150 flowers are marigolds. Does that make sense? And then they're saying 28% of the 150 flowers are petunias. Okay, so they're saying all of these things. So how do we find these individual things? We can do it by doing a percent proportion. Okay, that's a simple one. Or we can take, like, for example, we're finding the difference between impatiens and begonias. Well, impatiens is 36%. Okay, well, I don't know what 36% of 150 is off the top of my head, but I can multiply 150 times 0.36, and that's going to give me how many flowers are impatiens. So go ahead and do that for me. 150 times 0.36. Okay, so if you multiply it, we went through, we got that 6 times 0 is 0, 6 times 5 is 30. Okay, and then we carried that over and we got 6 times 1 plus 3 is 9. Marker spot, 3 times 0, 0, 3 times 5 is 15. Carrier 1, 3 times 1 plus 1 is 4. And that added up to be 54. So 54 of those 154 flowers are impatiens. Does that make sense? So what's the other one we're looking at? Begonias, 28%. So we would take 150 times 28. Make sure, multiplying decimals, you don't have to line it up. You just multiply and then make sure your decimal's there in the end. Okay. And I got 42. Okay. So 42 of those flowers are petunias. I'm sorry. Begonias. Oh, man, we should have been, I was doing petunias. We should be doing begonias. Okay, I'm sorry. So we should be doing 150 times 0.14. Okay, half of 28% is 14%. So if you know how to do that, you wouldn't even have to do this. But we'll go ahead and
it also
should be half of 42.
Are we doing the one with the B or the P?
We're doing begonias. We're doing the B. Should be half of 42, which is, I'm sorry, I was doing the wrong one. I got caught up. So 21. So 21 flowers are begonias. So we're looking for how many more? Okay, so how many more means subtract 54 minus 21, right? Which is 33. So, and that says that kind of right here, but I don't think sometimes y'all always understand this breakdown right here. So 33 more impatiens than begonias. Okay. How do y'all feel about that now that you kind of had a refresher? A little bit better? Coming back to you? Okay. Okay, so hold on. Okay, so here's the second graph. It says example 2. The circle graph shows the results of the enrollment of a school's fine art classes for next year. If there are a total of 400 students enrolled, what fraction of the total number of students are taking band? Okay, so we're looking at bands. Okay, right here, band is 40%. How many total students do we have? 400. So 400, and then I'm going to move this to a decimal, which is 0.4, right? Times 0.4. And I got 160. So 160 students are enrolled in band. Okay? Pretty simple, right? Could I do this as a percent proportion? Yes, I could have said X out of 400 equals 40 out of 100. Could I scaled up?
Yeah.
Times what?
4.
4. 40 times 4. So that might have been easier, actually. Anything to do with this percent, you can usually put it in a percent proportion. But sometimes you just want to multiply. I know y'all like to multiply, so. Okay, it says refer to the circle graph in example 2. How many more? Here, there's that wording again. How many more? So we're going to subtract. Are in band, then choir. So band we already know is 160 because we already found that, right? Okay, so choir is 26%. So we're going to say
Times 0.26.
perfect. Yeah, 400 times 0.26. Are y'all? So I got 104 for choir, 140 for band, 160, excuse me, 160. So I'm going to subtract the 2, and it's going to be 56. So 56 more people are in. Okay. Refer to the circle graph in example 1. Okay, this one's going back to example 1. What fraction of the flowers are marigolds? Okay, when asked for a fraction, it's asking for that part to whole relationship unless it states otherwise. Then you put it in the ratio. So like on 9-3, there was one that said total number to greater than 8 or something like that. And y'all wrote it as 4/20ths, and it should have been 20 to 4. So I marked that one wrong. Make sure it says right here, what fraction of the flower are marigolds. So of all the flowers are marigolds. So we're marigolds on top, total on bottom. Okay? So marigolds is 12%. 12%. Okay? So 12% of 150. And I got 18. And 18 out of 150. Can I reduce that?
Wait.
Is that not what you got?
Oh.
0, 1, 3, 0, 5, 1. Okay, so can I reduce that? They're both even, so what do? Divide by 2. Then I can divide by 3. Okay. Welcome, Rocky. Okay. So 3/25. This right here, that is over of, percent over 100, part over whole, percent over 100, amount of change over original, percent over 100. So we don't have to necessarily set it up in a percent proportion, okay? But, okay, so we're going to do this one real quick because I need to speed it up a little bit. It's getting along. Okay, the circle graph shows the results of the survey that asked 500 shoppers to pick their favorite of the 3 new ice blend. Okay, so 500 shoppers. What fraction of the total number of shoppers choose TA as their favorite? Okay, so TA is 44%. 44% of how many? 500. So we're going to say 500. And I'm going to do it this way. Why am I going to do it that way? Well, it doesn't matter, no. And then, but I only have to multiply once. I can do 0, 0. Only had to do one line.
220.
Did y'all see that? Okay. So 220. So 220 out of how many?
500.
500. Okay. Remember, we can always simplify the zeros. We can mark those out. So 22 out of 50 is where it would go after that. Okay, and then reduce that one more time. Divide by 2 would be 11/25. Okay. Number dos. Compare the total number of shoppers who were surveyed to the number of shoppers who chose TC as their favorite. Okay, this is just comparing. We just need to put it as a fraction and simplify it. So, what do they list first? Total number of shoppers. So that should be your first one. Remember, you can write a comparison in 3 different forms. You can write it as a fraction form, with a colon, or with the words to, right? So we could say 502 shoppers who chose TC. Well, TC is 30%. 500 times 30%, which would get 150.
What?
Okay.
Oh.
Could I reduce that?
Could you?
Can 50 go into 500? 10 times. 50 goes into 150 3 times, so it's a 10 to 3 ratio. So make sure you're writing it as a 10 to 3, not 3 to 10, because they say total numbers 2. There's that word. How many more shoppers chose TA than TB? We've done all of them except TB. So 500 times 0.26. Oops. Erase. I'm doing it the other way, because I only have to multiply once. Okay, so TA to TB. TA is 220. To TB is 130. You can simplify it by tens and get 22 to 13. Okay. And then write a ratio that compares the part of shoppers who chose that TC to the part of shoppers that chose TA. Express it. Okay, so we're just gonna, I'm not worried about this part. I want you to, okay, I want to express it as a ratio and then interpret its meaning. So, part of the shoppers that chose TC. So 150 to TA to 220. So then interpret the ratio's meaning. So what is that meaning?
The TC to TA.
Okay. So I'm going to go with more people like what? TA. Why? There's more people that chose it. So I could interpret it that way. What's the ratio's meaning? That TC is smaller. We could do it. We could go a lot of different ways. But I'm going to go with that more people like TA. Okay? So I want you to try this one on your own, and we're going to talk about it here in just a minute.